Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning. Today we will examine soil formation processes, focusing on weathering and organic matter accumulation, and how these processes interact to produce distinct soil horizons. Soil formation, or pedogenesis, begins with parent material, climate, organisms, topography, and time. I will concentrate on two interacting mechanisms, weathering of mineral material and accumulation of organic matter, and show how they create the physical and chemical properties of soils. First, weathering has two main modes. Physical weathering breaks rocks into smaller particles through freeze-thaw, wetting and drying, and root growth. Chemical weathering alters minerals at the molecular level. For example, feldspars in granite hydrolyze to form clay minerals and release cations. Quartz, by contrast, is very resistant to chemical weathering and often remains as sand-sized particles. The balance between resistant minerals like quartz and more reactive minerals like feldspar determines the texture and mineralogy of the developing soil. Climate controls the rate and dominance of weathering reactions. In warm, wet climates, chemical weathering is rapid and iron and aluminum oxides may concentrate, producing lateritic layers. In cold climates, physical weathering dominates and chemical reactions are slow. Now, organic matter accumulation. Plant litter and root inputs supply carbon and nutrients to the soil surface. Microbial decomposition transforms litter into humus through humification. The rate of decomposition depends on temperature, moisture, and the quality of the organic material. In a temperate forest, for example, cool, moist conditions slow decomposition, so leaf litter accumulates and a distinct organic horizon forms. In grasslands with high root turnover, organic matter becomes mixed with mineral particles, producing a thick, a horizon often called a molic horizon. Organisms such as earthworms, termites, and roots actively mix organic and mineral material. This bioturbation increases aggregation, improves porosity, and redistributes organic carbon into lower horizons. Earthworms in temperate grasslands commonly incorporate surface litter into the mineral soil. Weathering and organic accumulation interact. Organic acids from decomposing litter can enhance chemical weathering of minerals. Conversely, clay and oxide minerals influence how organic molecules bind, affecting the stability and protection of organic carbon. Leaching moves soluble products downward. In acidic forest soils with high rainfall, leaching can mobilize iron and aluminum and produce a bleached E horizon through alluviation. The material then accumulates lower down through alluviation, forming B horizons enriched in clay or oxides. To illustrate, consider podzol soils under coniferous forests. Acidic litter promotes strong leaching and translocation of organic metal complexes. This process produces a light-colored alluviated layer and a dark, organic-rich spotted horizon at depth. By contrast, mollisols in grassland regions develop thick, dark surface horizons because roots deposit organic matter directly into the upper mineral soils and limited leaching preserves base cations. Temporal scale matters. Early stages of soil formation may be dominated by physical disintegration and initial organic colonization. Over centuries, chemical weathering alters primary minerals to secondary clays and oxides, and organic matter equilibrates with mineral surfaces. We can measure the products of these processes. Particle size distribution indicates weathering intensity. Cation exchange capacity and concentrations of clay and organic carbon inform us about chemical weathering and organic accumulation. Radiocarbon dating of humus can estimate the age of organic pools. Finally, thinking about management and restoration. Understanding how weathering and organic matter accumulation operate helps predict soil resilience. For instance, maintaining plant cover preserves organic inputs and reduces erosion that would otherwise strip developing horizons. In summary, pedogenesis is a set of interacting processes. Physical and chemical weathering supply mineral constituents. Organic inputs and microbial transformation create and stabilize humus. Climate and organisms modulate rates and pathways and produce the diverse horizons we observe in soils. That concludes the lecture. Next, I will answer questions, and we will examine profile descriptions from real field sites to link these concepts to observations.
Listen again to part of a lecture, then answer the question.
In a temperate forest, for example, cool, moist conditions slow decomposition, so leaf litter accumulates and a distinct organic horizon forms.
This concludes the listening section. For more TOEFL practice tests and study materials, visit Spinta.org.